In the previous video, I discussed the first part of your data strategy, which is designing systems so you will have more data next year. The second thing you need to do as part of your data strategy is to break down data silos. It's important to have all the data organized in such a way that you can query it together and create an ML training data set. Recall how we said that ML is more powerful if you have more features, more distinctive attributes about your examples. If your data is spread throughout the organization and stored in different databases, you will need to build a culture of data sharing within your organization. The third part of your data strategy is to transition from data lakes to data warehouses. Why do I say that? Even if there is a culture of data sharing, the problem is that your data is spread throughout the organization and stored in different databases. No one will give an ML engineer access to their production databases. Even if they have a cluster on which they have a copy of their data, they're concerned that the ML person will take all their compute. So, the correct technical solution is to separate compute from storage. In other words, build a data warehouse. Then all that the other organization needs to do is to provide access to the data. Then, whichever department queries the data pays for their own compute. This is a principle behind Google BigQuery. You used it to build a model on bike share data. You didn't have to download the data or spin up a cluster. Serverless data analysis like this is one of the reasons why ML works so much better when your business runs on the cloud or if the historical data is available on the cloud. BigQuery is a data warehouse. That's where you want all your data to end up. But going directly to a data warehouse can be hard. Isn't there an intermediate stage? That's the idea behind data lakes. Move your historical data, all the data across the organization to the cloud so you can take full advantage of the separation of compute and storage and do machine learning on all the data. Of course, for most ML use cases, you want to continuously retrain and you want fresh data to do so. So the true answer is to move the systems that produce the data also to the cloud. And that's why I have a job. Data lakes are good, but this is essentially people tossing their data into the cloud. There is often no organization, no schema, no metadata. Data are not going to be all that useful unless you know where it is, what you can do with it, and what it is related to. When you have all your data in a data lake, all the data is available for you to join, but you will probably have to spend time understanding each data set and writing what we call ETL pipelines. Extract the data from the data lake, transform it to correct obvious errors, compute statistics like averages, etc., and then load it into the data warehouse. This will take quite a bit of time and probably a dedicated team of engineers to do. We tend to call the people in this team data engineers. They are programmers with experience in data processing, and they tend to use tools like Apache Spark and Apache Beam. I prefer Apache Beam because it can be executed in a serverless way on Cloud Data Flow.